So welcome students. In this video, let us look at the topic of transformation of roots. So if you have a quadratic equation ax square plus bx plus c is equal to 0. And let us say that the roots of this equation are alpha and beta. Now, what is an equation whose roots are k greater than the roots of this equation? So you have certain types of questions where you're asked a question like this. So if you're asked to find the equation whose roots are k greater than alpha and beta. That is, you want an equation whose roots are alpha plus k and beta plus k. So without actually finding the roots of this and increasing the roots of this, directly can you create an equation whose roots are alpha plus k and beta plus k from this equation? So this topic is called transformation of roots. So what we do is ax square plus bx plus c is equal to 0 is the original equation. Now let us say that x is the root of this. Now I want an equation whose roots are x plus k. So I take some y is equal to x plus k and I want an equation whose roots are y. A quadratic equation whose roots are y. So how do I get this? So y is equal to x plus k implies x is equal to y minus k. X is equal to y minus k. Now if x is equal to y minus k, but x satisfies this equation, so y minus k has to satisfy this equation. So you get a times y minus k whole square plus b times y minus k plus c is equal to 0. So this is the equation in y, which is a quadratic, and the roots of this equation are y, which is x plus k. That means if alpha is a root of this, alpha plus k will be a root of this. So we have effectively created an equation whose roots are alpha plus k and beta plus k just by substituting y minus k in the place of x. Finally, if you want the equation in terms of x, you can put x in the place of y. That is a times x minus k whole square plus b times x minus k plus c is equal to 0. As simple as this. For example, if you have a quadratic equation x square minus 5x plus 6 is equal to 0. We know that the roots of this equation are 2 and 3. Now if I want an equation whose roots are 5 greater than the roots of this equation, that means effectively I want an equation whose roots are 2 plus 5, that is 7, and 3 plus 5, 8. So how do I get this equation directly from this equation? So what you just need to do is, if you want the roots to be greater by 5, you just need to put x minus 5 in the place of x. So x minus 5 whole square minus 5 times x minus 5 plus 6 is equal to 0. So now once you write this, you can expand it later in the next step. So x square minus 10x plus 25 minus 5x plus 25 plus 6 is equal to 0. This implies x square minus 10x minus 5x is minus 15x. 25 plus 25 plus 6 plus 56 is equal to 0. So you can also find the same equation by back calculation. So if the roots are 7 and 8, what is the corresponding equation? X square minus of sum of the roots. 7 plus 8 is 15 times x plus product of the roots is 7 into 8 is 56 is equal to 0. So you can see that you got the exact same equation. What is the difference in these two processes? Here we have solved the original equation and increased physically by 5 and then found the equation. This is a cumbersome process because all equations cannot be solved very easily. So sometimes these roots will be complex, sometimes this root will be irrational, so on. So every time I cannot find the original roots, exactly increase them physically by certain number and then find the equation. This method is a more straightforward method. You don't need to solve this equation. You just put x minus 5 in the place of x. You get the equation. You solve it. You get the answer. So this type of process are called transformation of roots. If the original equation has roots alpha and beta, what should be done to the equation so that the roots get manipulated in different ways? So this is one way in which I can manipulate the roots. There are several other ways. If I want the equation whose roots are k times alpha and k times beta, this is one way. If I want the equation whose roots are squares of alpha and beta, another way. If I want the equation whose roots are roots of alpha and beta, so you can be given any type of question. So how do we solve these types of questions? So let us go further and see what substitutions we need to do in the place of x to get the required transformation of roots. So now let us look at the required transformations and the substitutions that we need to do to get the required transformations. So if you want the roots as alpha plus k and beta plus k, you need to substitute x minus k in the place of x. So the transformation can be obtained by simple working. So what you need to do is you just need to assume that y is equal to whatever transformation is asked. So in the place of alpha, just put x. So I want my y to be x plus k. This implies x has to be equal to y minus k. So this is the transformation. So now finally you want an equation in x. So put x in the place of y. So you have the required substitution. Now if you want the roots to be k alpha and k beta, k times alpha and k times beta. Here also the working is very simple. Let us assume y is equal to k times x. So this implies x is equal to what? X is equal to y by k, right? Y by k. So the required substitution is x by k. And if you want the roots to be alpha power n and beta power n, so you just need to put y is equal to x to the power n. So what is the substitution? X is equal to nth root of y. So you have to put the reverse substitution of whatever transformation you want. So you want minus alpha and minus beta, that is y is equal to minus x. This implies x is equal to minus y. So you get the same transformation. You just need to put minus x in the place of x. Similarly, if you want the reciprocal roots, so y is equal to 1 by x implies x is equal to 1 by y. So that's the required transformation. These are the standard transformations. You can also have some complicated transformations. For example, if you want an equation whose roots are alpha by 1 plus alpha plus beta by 1 plus beta. So the process is again straightforward. You have to see whether these two are same functions. Yes, something by 1 plus something, something by 1 plus something. So if you want to use the concept of transformation of roots, both the roots have to be transformed by a same function. Remember that. If you have here beta square by 1 plus beta and alpha by 1 plus alpha, you cannot do using this concept. So to solve this, you just need to assume y is equal to x by 1 plus x and try to find what x is. This implies y plus xy is equal to x. This implies y is equal to x times 1 minus y. So x is equal to y by 1 minus y. X is equal to y by 1 minus y. So the required transformation is x by 1 minus x. So if you want the roots to be alpha by 1 plus alpha and beta by 1 plus beta, the transformation that you need to do is x by 1 minus x in the place of x. So I hope you understand the logic of the transformation of roots. So if you are given any other transformation other than these types, you just need to follow the regular process. So you observe the function and put y is equal to in terms of x and find x in terms of y, and whatever you get, that's the required substitution.